Alright guys, so today we're going to talk about graphing not just some points but also lines and inequalities. Today's date is 4/27 and our topic or our title is graphing lines and inequalities. So you guys have seen this before. Alright, make sure you have this set up in your table of contents and then pause the video if you need to. I'm going to go ahead and get mine set up. Alright, so we are graphing lines and inequalities. So there are a couple ways to graph lines and inequalities. We're going to talk about doing it from a table option or table method. So you guys have learned how to evaluate functions, so now we're going to apply that and graph the lines ourselves. So if we have an example of f of x equals 2x plus 3, we can create a table of values, x and f of x, alright, which is 2x plus 3. That's our rule, okay, or our equation. And we can kind of pick whatever values of x we want. What you typically want to do, though, is if we remember our coordinate plane, the center piece is at 0, 0. So we kind of want to center it around the origin. So if we have -2, -1, 0, 1, and 2, see how we have negatives and positives and zeros in the middle? It's a little bit easier from when we go to graph. So now we're going to evaluate f of -2. So remember, when we're evaluating and we know the input, we're going to substitute that in for x. So 2 times -2 plus 3. We get -4 here, plus 3 is -1. So this is essentially my x, and this is essentially my y value, okay? So if I come on over here and I plot -2 on the x, and then I go down to -1, that's my first point. If I evaluate f of -1, then 2 times -1 plus 3 when I insert my input. 2 times -3 is -2 plus 1, I get +1. So now I'm going to plot the point -1x, +1y. Now we need to evaluate f of 0. So 2 times 0 plus 3. Anything times 0 is 0. So 0 plus 3 is just 3. So I'm plotting the point 0, 3. 1, 2, 3. I continue down, so I have f of 1 is 2 times 1 plus 3. 2 plus 3 is 5. So 1, 1, 2, 3, 4, 5. And then f of 2 is 2 times 2 is 4, plus 3 is 7. So we're going to go up to 2, 7. And then if you have a straight edge, grab it. I've got a tiny little one here. So I'm going to connect the line, or the points, and this is a line. We could continue to plug in any x we want, all right, and it will continue to give us a y. Or so my input, I can plug in anything and my output will come out. So what I want to do now is look at the pattern that we created in the table, all right? So every time my x increased by 1, my y, so I went +1, +1. From 0 to 1, I added 1. Do you see the pattern here? So for every change in x, my change in y, in order to go from -1 to +1, I had to add 2. Let's see if it stays consistent. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. So my slope is referred to as the change in y, or the rise, divided by the change in x's. This is referred to as my run. So my rise was 2 every time, and my run was +1 every time. So what that looks like on the graph is if I go from here, I go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. See how it's consistent from each point to the next? That's called the slope. Okay? Now, our y-intercept is going to be when we plugged in 0, right? Because on the y-axis, that is when our x is 0, because we didn't go left or right, we just went up or down. So when we plugged in 0, we got this point right here. Well, that is this point in our table, right? We evaluate f of 0. 2 times 0 is 3, and we're left with the 3. So my slope, we can actually find that in our equation at 2. And my y-intercept, I can find it here as well. And that leads us into our next way to graph an equation, is by doing it in slope-intercept form. So let's look at a different example. And let's try a negative example. So if we have f of x equals negative, let's make it a fraction, 4th x plus 2. Well, our y-intercept is going to be when we plug in 0. So if we evaluate f of 0, it's negative 1/4 times 0 plus 2, which is just 2. And then we want to look at our slope, which is going to be that negative 1/4. So we always go change in y divided by the change in x. So my slope is, and we always put the negative up top, all right? So my slope is going to be negative 1/4. And if we write that in terms of like the words, that means we go down 1, and then this 4 is positive, so it is right 4. So if we come over and we graph this, instead of making a table of values, which we could do, we would start on our y-axis. We would start on our y-axis at our y-intercept, okay? So our y-intercept is going to be the point 0, because that's the x, 2. And I'm just going to add my tick marks real quick so I can put them in. Okay, so we go to 0 on the x, and then up to 2, okay? So that's my y-intercept. And I'm going to highlight that just to remind myself that's like my starting point if I'm graphing it this way. My slope, I need to go down 1 and then right 1, 2, 3, 4. So that's going to be my next point. Okay? Well, just like in this problem, see how it repeats this way? We can have it, so we want to take this and put it here. All right, so if we go down 1 and right 4, we need to end up at our next spot. So we could do the opposite. So left and up will put us at another point that would continue the same pattern. Okay, so we could go down 1, right, 1, 2, 3, 4. My next one's going to be right at the end of my arrow. Then we can go left 4, up 1. We need to continue the steps. Do you see the little step stones? Okay, so now if we grab a straight edge and we connect these points, we have our line. And we're going to add arrows to the end of the line because it continues forever. All right. So that's how you start off with a line. Okay. Now, what we're going to do is make sure we know how to do this thing called an inequality. All right, so that is our greater than, I'm sorry, that's less than. Greater than, less than, or equal to, or greater than, or equal to. So that's when we're going to get into the shading, okay, and solid line versus a dashed line. So we're going to make a little table, and we're going to say that if y is greater than, then we're going to shade above, and we are going to have what's called a dashed line. Okay, think of it this way. See how there's no or equal to down here? So the line itself is not included in the solution set because it can't be equal to y. It has to be just greater than. If it's y is greater than or equal to, we're still going to shade above because it's greater than. And this time, see that line here? It's going to be solid. Okay, so it is solid when we have this line. So let's look at if y is less than. We're going to shade below. And is it going to be solid or dashed? Dashed. If y is less than or equal to, we're going to shade below. And this time, again, we have a solid line down here, so it's going to be a solid line when we connect the points. Okay? So, real quick, I'm just going to do a small little example over here. If we have y is greater than x minus 2, if we use our slope-intercept form, then my slope is this invisible 1, so it is a 1 over 1, and my y-intercept is that last number, and we include the sign, negative 2. So if we draw our little thing here, we're going to start at negative 2 on our y-axis. Whoop, that's supposed to go right there, sorry. So we're going to start at negative 2. And our slope is rise 1, run 1. So we rise 1, run 1, rise 1, run 1. And we can just kind of do this over and over again. And then anytime that we come to like a vertex that's on the line, we're just going to put a point. And we can repeat it in the opposite direction. Okay. So now we have to take into account our sign. So we want to match this sign, greater than, to over here. So greater than is here. So first thing we want to do is look at either the shading or the dashed. We have to do both. So we need to shade above. So if you look at that y-intercept and we draw a line above would go up and below would go down, then that means we're going to shade everything on that side. We're always going to look at our y-intercept for that. We just take a point and we go straight up for above. And then our line is dashed. So instead of connecting these in a straight line, I'm just going to put like a little dash between the points instead of actually connecting the points. Again, we do have arrows. Okay. So what this means is that any point in the shaded area are solutions. Okay. And over here, these are not solutions. Okay. As well as the line is not solutions. So no solutions on the line because it's dashed. So line is not a solution for this one and here. Not a solution for the line. Okay, so that's the end of the notes for this one. Sorry the video is so long. Go ahead and get started on your practice.